Okay, so let's go through section 3.5 on collecting like terms. So algebra tiles are made up of integer tiles and variables. So algebra tiles are going to help you solve more complex problems. The thing to note here is that if they're filled in, they represent positive values. So for example, this small square here would be positive 1. This rectangle here would be positive x. And this bigger square would be positive x squared. If they're not filled in, they're just the negative version of the positive ones. It says here terms that have the same variable with the same exponent on that variable are called like terms. So for example, 2x, negative 6x, and 452x, and negative 19x would all be like terms because they all contain the variable x, and the exponent on this variable is 1. Something like 5x squared would not be a like term because although it contains the variable x, the exponent on this variable is 2, and it's not the same as these other ones. Something like 3xy would also not be a like term because even though it contains the variable x, it also contains the variable y, and so it's different from all of these. We organized the following algebra tiles into groups of like terms, write the algebraic expression that they represent. So I want to group up things that are the same. Now remember, these big blocks are x squareds, and it looks like I have 2 of them. Next, I can look at these rectangles. Remember, those are positive x, and it looks like I have 3 of them. And lastly, we can look at these small little squares, and remember, those are positive 1s, and it looks like I have 5 of those. So if I were to put this all together, it looks like I have 2 of the x squareds, and I have 3 x's, and I have 5 of the number 1 cubes. So the equation that's represented by these algebraic tiles is 2x squared plus 3x plus 5. Write the algebraic expression that is represented by each group of algebra tiles. It looks like I have 2 of the x squareds, and they're positive. It looks like I have 2 minus x's. So I have 2 of the negative x's, and it looks like I have a minus 1 given by that small square. In example B, it looks like I have a negative x squared, and it looks like I have 3 negative x's, so minus 3x, and then it looks like I have 3 positive 1s represented by those small blocks. So I could write plus 3. There we go. Those are my 2 equations. I think we'll stop there for now, but make sure you tune in for part 2.